This video is about drawing and interpreting Venn diagrams. A Venn diagram can be used to represent events graphically. So in a Venn diagram, we have a rectangular part, which represents the sample space. S is equal to the sample space. And then you have these closed curves, closed circles, closed ellipses, which represent events. Okay, notation-wise, A, so they might be A and B events. So A intersect B, so we say A intersect B means A and B. So both A and B occurring. A union B means A or B, which means at least one of A or B occurring, or both. So either A occurring or B occurring or both occurring. A dash is the complement of A, means not A. So event that A does not occur. So if I have to draw these intersections, these notations as a Venn diagram, A intersect B will be A and B. If this is A and B, then A intersect B is both A and B happening, so it'll be this part in the middle. So this is A intersect B. Okay, A union B. A union B is A or B or both. So all these three parts are included. And the last one, which is not A, A and B, so not A would be everything that is not A. So if you think about the circle that represents A, then everything that's not in that circle is not A. So that means everything on the outside and the part of B that is not A. Okay, sort the integers 1 to 10 into the following Venn diagram where A is equal to a prime number and B is greater than 5. So prime numbers less than 10, less than or equal to 10 will be 2, 3, 5, 7. B is equal to greater than 5 will be 6, 7, 8, 9, and 10. Now you can see clearly the only number that comes up in both is 7. So 7 will go in the intersection. In A, everything apart from 7 will go on the part that just represents A. So that's 2, 3, and 5. In B, everything apart from 7, so 6, 8, 9, 10 will go in the part that represents only B. And the numbers that don't occur in both are 1. So 1 should go outside the bracket, outside the two circles, and we haven't got 4. So 4 is outside as well. A probability of A is everything that is in A So if we think about it, everything that is in this part of the circle, you can see 4 numbers out of 10. So that would be 4 out of 10. Everything that is in B would be everything that's in the circle representing B. 1, 2, 3, 4, 5. So that would be 5. Oops, undo. Equal to 5 out of 10. Probability of not A will be everything that is not in the circle A. So if you highlight the circle A, every number that is not in that circle. So 1, 2, 3, 4, 5, 6. 6 numbers are not there. So it's 6 out of 10. Probability of not B will be everything that's not in B. So 1, 2, 3, 5, and 4. So that means that's 5 numbers. So 5 out of 10 altogether. A intersect B is everything that is in the middle, because it's both A and B, which is just 1 number. So just be 1 out of 10. A union B is everything that is in A, B, and in the middle. So that means we've got 1, 2, 3, 4, 5, 6, 7, 8, 8 out of 10. Draw Venn diagrams to represent the following. Probability of A. So probability of A is just everything that's A, so it's everything that's inside the circle A, which means it's just both these parts. Probability of B will be everything that's inside the circle here, so it's that part. Probability of not A is everything that's not in A. So if we highlight the circle A, everything that's not inside the circle is probability of not A. So it's that part and the outside part. Okay, probability of A intersect B is A and B. So both A and B, which is the part in the middle. Probability of A union B means it's not, so it's A or B or both. So if you think about it, it's A or B is just, and or both means it's everything in the middle as well. Not A and not B. So not A and not B is everything on the outside, because it's not A and it's also not B. So if you can't see that very easily, what you can do is you can do it via each one individually. So if you think about not A, I'm going to do a tick, blue tick for not A. Everything that's not A is this part and that part. And then if I think about not B, everything's not B is going to be in red. Not B is this part and this part. Now the part that has both ticks, so both a blue tick and a red tick, oops, undo, and a red tick will be A, not A, intersect not B. And you can clearly see that the only part that has both a red and a blue tick is the part on the outside, which I've highlighted already. Okay, so let's use a similar technique to do this one. So A, if I want to do A in a blue tick, then that would be blue, blue. Red is not B, so we're trying to do A intersect not B. So what is not B? Not B is that part and that part. So which part has both ticks? Because it's intersect, so A intersect not B will be the part that has both ticks, which is just this part. Okay, union is different because it's any tick, whether it gets 1 tick, 2 tick, or both ticks, okay? So A is blue tick, so here. And then we're doing not B. Not B is this part and that part. So this is red. So if I'm trying to find A union not B, it's everything that's either got 1 tick or blue tick, red tick, or both ticks. Or both ticks, okay? So basically what you need to do is get a highlighter. Anywhere you see a tick, you just shade it in. So the only part that doesn't have a tick is the part of B that is not part of A. So everything else besides that. Okay, let's go to the next one. So it's a union, so it doesn't matter as long as it gets a tick. So not A is equal to blue tick, not A is this part and that part. And then I need to do not B, which is equal to that. So not B is this part and that part. So if I'm looking for A dash union B dash, or not A union not B, is anything that's that. So one tick, one blue tick, one red tick, or both. So if I use my highlighter to do that, then I end up getting this part. So shading this part and shading that outside. So the only part that's not shading is the intersection. So that would be it. So remember, if it's intersect, it's the parts that are ticked by both colors. But if it's union, it doesn't matter, one tick or both ticks, it will work. Okay, next question. In a group of 100 students, 50 study maths, 29 study biology, 13 study both. Draw a Venn diagram and use it to find these probabilities. So always start with a Venn diagram, always start with the middle. So 13 study both, so 13 would go in the middle. Okay, 50 study maths, so 50 take away 13 will give me the part that's on just M. So 50 take away 13 is 37. So 37 here. And 29 take away 13 will be just biology, which is equal to 16. If I do 37, so if I do 100 take away 37, take away 13, take away 16. So 100 take away 37, take away 13, take away 16 must be that part on the outside, which is 34. So make sure everything adds up to 100. Make sure you think about the number on the outside of the circles. Probability of maths is everyone that does maths, which was already given in the text, which is 50 out of 100. Probability of biology has already been given in the text, which is 29 out of 100. Probability of M union B is this, undo. M union B is everything that is maths, biology, or both. So it's going to be 37 plus 13 plus 16 over, so 37 plus 13 plus 16 over 100, which is equal to 66 over 100. M intercept B is the part in the middle. This is both M and B, so it's going to be 13 over 100. Probability of not maths is everything that is not maths, which is that number and that number. So 16 add 34, which gives me 50 out of 100. Probability of not B is everything that's not B, so it's this number plus that number out of 100. 37 plus 34 is 71 out of 100. M and not B, maths, and not B is just people who study maths, which is 37 over 100. Not M at union not B. Okay, this is quite hard. So not M. So I can use ticks to do this. So not M. Not M is, maybe use a different color. So not M is everything that's not M. So here and here. And if I use a different color, everything that's not B is this one and that one. So all we have to do is add, no matter which color, because union, it doesn't matter as long as you've got a ticked, you include it. So 37 plus 34 plus 16 out of 100, which gives us 87 out of 100. So the last one is not M intersect B and then not. Okay, so this one is a bit difficult. So not M, so I might want to draw a diagram. So not M intersect B, so not M and B. Not M is this one and that one, and then B is just this one and this one. So what we want is M dash intersect B is the part that is both, so is that part. But then we want the complement of that, which means we actually want the green part, which is everything else. So everything else but the yellow part. So that is 37, oops, undo, let me just use blue. Which is 37 plus 13 plus the 34 over 100, which is equal to 84 out of 100. So it always helps to draw a diagram and try to figure out which part you want. Next question. There are 84 teenagers at an activity center. 51 of them did sailing. 35 of them did abseiling. 11 of them did neither sailing or abseiling. So the best ones to start off with is always the last one, which is 11 on the outside. Okay, so we know there's 84 altogether. So 84 take away 11 gives us what remains, which is 73. Okay, but if we add 51 and 35 together, we are getting 86. So we're getting an extra few. So these must be in the intersection. So 86 take away 73 is equal to 13 is S intersect A, because those are the parts where they've been counted more than once. So this is 13. 51 take away 13 is equal to 38. So that part must be 38. And 35 take away 13 is equal to 22. So we must have 22 here. So all the Venn diagram has been filled in. Find the probability that a teenager chosen at random took part in either sailing or abseiling. So this is probability of S union A, which is equal to this, because it's one or the other but are both, which is equal to 38 plus 13 plus 22 out of 84, which is equal to 73 out of 84. Part B, both sailing and abseiling is S intersect A, which is the part in the middle, which is 13 out of 84. C, only one of these activities. So that is probability of S intersect not A plus probability of A intersect not S. So that is just this plus this, which is just going to be equal to 38 plus 22 out of 84, which is equal to 60 out of 84. Next, the addition rule. So the addition rule states that probability of A union B is equal to probability of A plus probability of B minus probability of A intersect and B. So if I draw my diagram, just to prove this addition rule. So I have A and B. So the first thing I need to do is probability of A. Probability of A means I need to include these two parts. So this is equal to probability of A. If I do probability of B next, in green, probability of B, then it'll be that part and that part. Now you can see clearly that we've included the middle bit twice, so we need to take off one of the parts in the middle to get the union, because the union is just that three parts together. So that's why we end up with the formula probability of A union B, because we have to take one part off, is equal to probability of A plus probability of B minus probability, because we need to take one of these off. Let's just do it in blue. We just have to take one off, which is the middle, which is probability of A intersect B. Okay, so this is known as the addition rule. And similarly, we can rearrange it. Probability of A union B is also equal to probability of A plus probability of B minus probability of A intersect B. Oh, the other way around. And I didn't write it the right way, I've just written the same thing. So it's probability of A intersect B is equal to probability of A plus probability of B minus probability of A union B. So it's addition formulae rearranged. Okay, the integers 1 to 20 are written on cards, and one card is selected at random. Find the probability the card chosen is even. So if I think about the cards that are even, it's 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. Probability that, so multiple of 3, let's call it M3, is equal to 3, 6, 9, 12, 15, and 18. So we're going to do this not using a Venn diagram, because if I were to draw a Venn diagram out, oh look. Actually, I can draw it out now. Now that I've listed it, let's just draw it out. So even and multiple of 3. Then how many numbers do I have here? 1, 2, 3, 4, 5. So how many overlaps do we have? So we have 6 that comes up in both, 12 that comes up in both, and 18 that comes up in both. So we can put probabilities in here. So that would be 3 out of 20. I don't know if that's clear. So let's just make it a bit bigger. 3 out of 20. Everything else goes in E. So that's 1, 2, 3, 4, 5, 6, 7. So it's 7 out of 20. 1, 2, 3. 3 out of 20 here. So altogether we've got 13. So there must be 7 outside here. Okay, A. Even number is, we already worked it out. Probability of even, there were 10 possibilities, so 10 out of 20. And 7 over 20 plus 3 over 20 is 10 over 20. B is a multiple of 3. You can see clearly there's 6 numbers there, so 6 out of 20. C, probability of even and a multiple of 3. Even intersect multiple of 3 is equal to 3 out of 20. And D, probability either even or multiple of 3. So we can use the addition formula to show this, or let's just do it as on its own. So even union multiple of 3 is 7 out of 20 plus 3 over 20 plus 3 over 20, which is 13 over 20. And let's check that it does work, that it does follow the addition rule. So probability of E plus probability of multiple of 3 minus probability of E intersect multiple of 3. So 13 out of 20 must be equal to 10 out of 20 plus 6 out of 20 minus 3 out of 20, which does make sense. So it does work. Okay, mutually exclusive events. Events A and B are mutually exclusive if they cannot occur at the same time. i.e., probability of A intersect B is equal to 0. So the probability of both of them occurring at the same time is equal to 0. So if you think of the Venn diagram, then if we have A and B, the probability in the middle is 0. Let's draw it properly. The probability in the middle is 0, which means no probability in the intersection, so it's 0. 0 probability, I should say. zero probability in the intersection, which implies if I were to draw it out really, because the probability is 0, then we should draw it separately. So A and B have no intersections. So events have no overlap. So A and B are mutually exclusive, then you can draw them separately without an intersection. Then the addition rule, which is probability of A union B, is equal to probability of A plus probability of B minus probability of A intersect B, but this is just equal to 0, which means probability of A union B is equal to probability of A plus probability of B, which is the addition rule from GCSE, but this only works when A and B are mutually exclusive events. And I would say this is A. So these are the two things I need to remember. Okay, so next one, Q and R are two events such that PQ is equal to 0.2 and PR is equal to 0.4 and P of not Q and R is equal to 0.4. So if I were to draw it out, a Venn diagram, then I know Q, oops, I'm happy with my diagram. So I've got probability of not Q and R means it's this part. This part is 0.4, but then I've been told that probability of R is 0.4. That means that must be 0. And that means P of Q is 0.2, so this must be 0.2, which means I can redraw this as, because it has the intersect is equal to 0, then that means that I can draw them separately, 0.2 and 0.4, which means Q and R are mutually exclusive events. So Q and R are mutually exclusive events since probability of Q intersect R is equal to 0. B, probability of Q union R, because they're mutually exclusive events, is equal to probability of Q plus probability of R, which is equal to 0.2 plus 0.4, which is equal to 0.6. And C, probability of not Q intersect not R. All probabilities add up to 1, so 0.2 plus 0.4. So 1 minus 0.2 minus 0.4 is equal to 0.4. So the outside is 0.4, which is not Q and not R. So it is equal to 0.4. Two fair dice are rolled, and the result on each die is recorded. Show that the event the sum of the scores on the dice is 4, and both dice land on the same number are not mutually exclusive. So sum of the two scores on the dice is 4. How many possibilities do we have for this? So you can have 1 and a 3. So that's one. Roll a 1 and then roll a 3. Roll a 2 and then a 2. And roll a 3 and then a 1. So that is 3 out of 36 possibilities in total. Okay, and if I think both dice land on the same number, is equal to obviously 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6, which is 6 out of 36. Now the overlap is the intersect, so the only number that comes out in both is 2, 2. So sum of two scores on a dice is 4 and both dice land on the same number is equal to just 2, which is 1 out of 36. Now, because there's an overlap, if it was mutually exclusive, the sum of those two must be the same. So probability sum of two scores on dice is 4, or both land on the same number is equal to 3 out of 36 plus 6 out of 36 minus the intersection, which is 1 out of 36, which is equal to 8 out of 36. Now, 8 out of 36 is not equal to 3 out of 36 plus 6 out of 36. Because if it was mutually exclusive, then the probability of both of them happening will be, one or the other happening will be the same thing as adding the two probabilities up. So, therefore, not mutually exclusive. The diagram shows the facilities used by 206 members of a health club. A member is chosen at random. Find the probability that they used a gym. Use just the gym. If it's use just the gym, it's just going to be the part that's just the gym, which is that part, which is just 15 out of 206. B, use the pool. So the pool is this part, this part, this part, and this part. So everything within the pool circle. So if I add these numbers together, I end up getting 20 plus 27 plus 41 plus 26 out of 206, which is equal to 114 out of 206. C, use the gym and pool but not the sauna. So gym and pool is this bit, but obviously that's part of the sauna, so that means just the 20. So 20 out of 206. D is did not use the gym. So did not use the gym is this plus this plus this plus this. So that's going to be 26 plus 41 plus 17 plus 43 all over 206, which is equal to 47. No, it's not 47, 127 out of 206. Someone who used a gym is chosen. Find the probability that they also used the pool. So if that means a new sample space is just in the gym. So only the people from the gym, and then from the people in the gym, we're only looking for the people who also use the pool. So it's just those part. So it's going to be 20 plus 27 all over total for the gym, which is 15 plus 20 plus 17 plus 27, which is the same thing as 47 out of 79. The probability that a child in school has blue eyes is 0.27. So blue eyes 0.27. And the probability that they have blonde hair is 0.35. The probability that the child will have blonde hair or blue eyes or both is 0.45. Okay, so probability of blue eyes is equal to 0.27. Probability of blonde hair is equal to 0.35. And then probability of blue eyes union blonde hair is 0.45, which means we can use the addition law to find probability of blonde hair intersect blue eyes is equal to probability of blue eyes plus probability of blonde hair, minus probability of blue eyes union blonde hair, which is equal to 0.27 plus 0.35 minus 0.45, which is equal to 0.17. So now I can draw a Venn diagram. So it's blue eyes, blonde hair, the middle is 0.17. If I want to find this part, it's 0.27 take away 0.17, which is 0.1. 0.35 take away 0.17 is 0.18, so this is 0.18. If I add these all together, I get 0.45, so that means the outside part is 0.55. Okay, part B, probability of blonde hair but not blue eyes intersect not blue eyes. So blonde hair but not blue eyes is just this part, which is 0.18. And C, neither features is not blonde hair intersect not blue eyes, which is the part on the outside, which is 0.55. Okay, the Venn diagram shows the probabilities of members of a sports club taking part in various activities. A represents the event that the member takes part in archery, B represents the event that the member takes part in badminton, and C represents the event that the member takes part in croquet. Given that probability of B is equal to 0.45, A, find X. So probability of B is equal to 0.45 implies X plus 0.1 plus 0.2 is equal to 0.45, which means X is equal to 0.45 minus 0.1 minus 0.2, which means X is equal to 0.15. B is find Y. I know all the probabilities added together equals 1. So sum of probability is equal to 1, which implies 0.35. X is already 0.15. So 0.35 plus 0.15 plus 0.1 plus 0.2 plus y plus 0.05 is equal to 1. If you add all these numbers together, you get y plus 0.85 is equal to 1, which means y is equal to 1 take away 0.85, which is equal to 0.15. The Venn diagram shows the probability that the students at the sixth form college study certain subjects. M represents the event that the student study maths. P represents the event that the student studies physics. H represents this event that the student studies history. Given that probability of M is equal to probability of P, find the values of P and Q. So probability of M is equal to probability of P implies probability of M is just, I think about it, is 0.32 plus P. So 0.32 plus P is equal to probability of physics. Probability of physics is P plus Q plus 0.07. So is equal to P plus Q plus 0.07. So let's repeat this out. So the P's can cancel out. All I'm left with is 0.32 is equal to Q plus 0.07, which means Q must be equal to 0.32 minus 0.07, which means Q is equal to 0.25. Now that I know what Q is equal to, P must be equal to, sum of P is equal to 1, sum of all the P's, so probabilities I mean, which implies that 0.32 plus P plus Q, which is equal to 0.25, plus 0.07 plus 0.13 plus 0.1 is equal to 1, which means if I add everything on this side, I get P plus 0.87 is equal to 1, which means P is equal to 1 take away 0.87, which is 0.13. The Venn diagram shows the probability of a group of children liking 3 types of sweets. Given that probability of B is equal to 2 times probability of A, and that probability of not C is equal to 0.83, find the values of P, Q, and R. Okay, so probability of B is equal to 2 times probability of A. implies probability of B is just P plus Q plus 0.05. So I get P plus Q plus 0.05 is equal to 2 times, let's swap this out first, probability of A, and probability of A is just 0.15 times P. So 0.15 times P. Plus P, sorry, plus P. 0.15 plus P. If I simplify P plus Q plus 0.05 is equal to 2 times 0.15 is 0.3 plus 2P. Which means I end up getting, if I subtract P, I get Q plus 0.05 is equal to 0.3, so minus P from both sides, 0.3 plus P, which means Q is equal to 0.25 plus P. This is my equation 1. Okay, probability of not C. Probability of not C is equal to 0.83. Means I have everything that's not C is this, 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 and this, which means P plus Q plus 0.15 plus 0.2 is equal to 0.83, which means P plus Q 0.83 minus 0.2 minus 0.15 is equal to 0.48, which means P is equal to 0.48 minus Q. That is my equation 2. So I can substitute 2 into 1. So substitute 2 into 1. Then I end up getting Q is equal to 0.25 plus 0.48 minus Q, which means 2Q is equal to 0.73, which means Q is equal to 0.73 divided by 2, which is equal to 0.365. Okay, now I need to substitute Q is equal to 0.365 into, let's just do it to 2. Then I end up getting P is equal to 0.48 minus 0.365, which is equal to 0.115, which means P is equal to 0.115 and Q is equal to 0.365. Now we need to find R. Okay, so we know probability of not C is equal to 0.83, which means probability of C must be equal to 1 take away 0.83, which is 0.17. So that means if I look at my diagram, that 0.05 plus R must be equal to 0.17. So that means R plus 0.05 must be equal to 0.17, which means R is equal to 0.17 minus 0.05, which means R is equal to 0.12. That's done. Shade the following in the Venn diagram. Okay, so first one is probability of G intersect P intersect S is just the middle part. G union P union S is everything that's G or P or S or both or all. Yeah, so everything that's one or the other, all the different combinations you can get. G intersect S, so G intersect S is this part. So I'm doing the working out. So G intersect S is this part, but we also want it to be not P. So it's just going to be this part. So we're just going to have, oops. So G intersect S was this bit, but we also want it to be not P. So we end up with just that part. So it's just this part. Okay, next one, probability of So let me just write this as 1, 2, 3. So 1, 2, and 3. This is 4. So not G and not S and not P. That part is just everything on the outside. Okay, next one. 5. P intersect not G intersect not S. So if you think about it, P is here. Everything that's not G and not S is just that part. So I just need to highlight this part. So that was 5. Next is 6. So S union P. So S union P is just all of this. But we also want it to be intersect not G. That means we want that part, and that part. Okay, so if we think about it, we want just S union P, but not G. So we want just these 3 parts. Okay, 7. P intersect not G. So P intersect not G is, so P intersect not G is just this part. Okay, so we want that part. But we also want S, so everything that's S. So it's just everything here. So we just don't include those 2 parts. So if I were to remember, P intersect not G is this part. And then I want all of S because union, so I want S. So it's that part as well. Okay, next one is 8. Which is G intersect P. So G intersect P is easy. So everything that's G and P. So we disregard S and it's just that part. 9 is G union P, which is everything that's G or P or both. Disregard S. So it's everything here. Okay, it says find the algebraic expression for the shaded region. How would you describe this in Word? Okay, so I know this is G union P. So G union P would be all of this. But we only want the part that's also part of S. So it will be G, undo. It will be G union P, which is all the green part, intersected with the part that's S. So you can either write probability of G union P intersect S or just that. So that would be it.